Okay, Assalamualaikum. So, video ni akan cover topic 1, physical quantities and measurement. Okay, there are 3 subtopics under this topic. However, in this video, I will be covering the first 2 only. The first subtopic is dimensions of physical quantities. There are 3 parts under this topic. First, you need to know what is dimension. Next, we're going to determine dimension for derived quantities. And last one, we are going to use dimensional analysis to verify homogeneity of equation. Okay. Before we proceed, let's have a look at these terms first. Okay. So physical quantity. Physical quantity is any quantity that you can measure. Okay. For example, time, length, mass, weight, force, energy, power, magnetic field strength, current, torque, anything. Okay, as long as you can measure it, and there are physical quantities. Okay, and these physical quantities is divided into 2 types. Okay, the first one is base quantity. Okay, basic quantity. It means that it is in the most basic form. You cannot derive it anymore, meaning you cannot expand, it doesn't have any formula and so on. Okay, so it is in the most basic form. There are only seven basic quantities. Okay, other than these seven physical quantities, they are all called derived quantity. Okay, derived quantity, you can derive it based on basic quantity. Okay, as long as you have formula for it, it is a derived quantity. Okay, so take note on these 3 terms. So part A is where we define dimension. So what is dimension? Dimension is actually a technique or a method, okay, technique or method which relates physical quantities. Okay, so you have physical quantities, but you want to show it in the most basic form. Okay, alright, so let's have a look at this table. Okay, if you look at the left hand side, those are the list of basic quantities. Okay, so you have mass. Look carefully. At that column, we put square bracket. Okay, square bracket indicating that you are doing dimension to that physical quantities. Okay, so you can write down, let's say the first row there, mass. So just put square bracket there. So that is dimension for mass, or just write down the symbol for mass, which is small m. However, symbol for dimension is capital M there for mass. Okay, for symbol dimension, you cannot put square bracket. Okay, so if you look here, this part, okay, this part you put square bracket, indicating here that you are doing dimension to that physical quantities. Note that for symbol dimension, you do not put square bracket to them. Okay, for your syllabus, matriculation syllabus, you are going to use the first 3, M, L, and T. So capital M is for mass, capital L is for length, capital T is for time. Okay, example, if you want to write down dimension for physical quantity, you put square bracket to that physical quantity, or you can write down the symbol for that physical quantity, which is L, small l in this case, or you write down the symbol for dimension. Take note that when you are writing down symbol of dimension, you do not put the square bracket. Okay, let's have a look at another example, height. So you just put a square bracket for height, or simpler version, just small h indicating its height. However, for symbol dimension, for height is not capital H, okay? Because there's only one dimension for length, and height falls under length category. Therefore, dimension for height is actually capital L, okay, which stands for length. Okay, so part A done. Now part B is where you determine dimension for derived quantity. So you now know what dimension is, right? Okay, so if given to you any physical quantities, you should be able to determine its dimension. Okay, how? Okay, here I already laid out the steps to do so. Okay, FDS. FDS. First formula, it is displacement over time. Okay, I write down the symbol for displacement in time only. Okay, then second step, dimension them. So just put dimension for my physical quantities here, and then state the symbol, the dimension symbol for that physical quantities. So displacement falls under length dimension, T falls under time dimension. So done. This is the most basic form, right? Therefore, write down, simplify or write down it properly, which is LT negative 1. T we bring up, you get LT negative 1. Okay, so this is dimension. Okay, so remember FDS. Let's look at another example. You have pressure. Okay, formula for pressure is force over area. Okay, force is not basic quantity, area is not basic quantity. Okay, but we still want to do dimension for them. Okay, let's say I'm going to just put square bracket to show that I'm going to do dimension to these physical quantities. Okay, next, what I'm going to do is, since I know what dimension for force, so I can just simply write it down. Okay, I know force is mLT negative 2. And then I know area is length squared. Okay, what if you don't know the dimension for force? So you do dimension for force first. So force is equals to what? MA. So M is mass, A is LT negative 2. But what if you don't know the dimension for A? So you need to do FDS for A, which is velocity over time. What if you don't know the dimension for velocity? So you need to do for FDS for V. Okay, until the equation or the dimension is in basic form. Okay, alright, so see, back to this force here. Area is length times length, right? So therefore length squared. So I've done first part formula, I've done second part as well, dimension, and the last part is simplify them. So I have L here, which I can cross out with one of L down there. So I got M, and then I got T negative 2, and then L here, I'm going to bring it up, so I get L negative 1. So this is dimension for pressure. So remember, in order to determine a dimension for physical quantities, you should know these three symbols of dimension, L, M, T. Next, part C. Part C is where you do dimensional analysis. Okay, heads up. What you did just now in part B, you are determining the dimension for physical quantities, right? So what you are doing actually is dimensional analysis. Okay, so dimensional analysis is actually to check whether your mathematical relation or equation is consistent in terms of their dimension. Okay, so under your syllabus is these two. So first you can check whether that equation is homogeneous. Okay, check homogeneity of equation. What does homogeneity means? Okay, homo means one, right? Or same. Okay, alright, so it means that when you want to check homogeneity of equation, you want to check whether the left hand side is equal with right hand side. Okay, that's when you use dimensional analysis. And then you can also determine unit for physical quantities. If you don't know any particular unit for physical quantities, you can use dimensional analysis. Okay, to help you understand more on how to do a dimensional analysis, let's look at this exercise. Okay, you can refer to your lecture notes, it's in there. Okay, I'm going to explain to you how to do dimensional analysis. Okay, so I'm just going to do for part A here. Alright, so given to you this equation and it asks you determine whether it is dimensionally correct or not, or in other words whether it's homogeneous or not. Okay, so what you are doing is to check whether it's dimensionally correct, you need to check whether it's left hand side is equal to right hand side. Okay, based on this information, I'm going to transfer it here. So these are the information given in the question. Okay, this part here. So I'm going to write down again the equation. Alright, see the equation here. So what I did is I put dimension for each physical quantities. So I know V is speed. Okay, and then A here, right? A here is stated in the question. It is dimensionless constant. It is a constant. Constant is dimensionless. Another thing that dimensionless is numbers. Okay, and sign, positive, negative. Okay, it's dimensionless. Alright, so that's why in this second step here, you don't see any A here. Okay, because it's dimensionless, it's actually equals to 1. Okay, but you don't have to write down. Right, so X here is width, rho here is density, and this coefficient here. What you did here is expanding the physical quantities, okay, so that you can write down the dimension clearly. Okay, speed is distance over time, width is width, okay, is in the most basic form. Density is mass over volume, and then coefficient here, you don't know the formula for coefficient, but given to you the unit, given in question is unit. So from here you can actually reverse. Okay, from unit you change it into dimension form. Okay, so kg is mass. Okay, kg is mass. Meter here is length. Second here is time. So you reverse it so you get dimension here. So you can put all the symbol for dimension for each physical quantities that you have expanded here. Therefore, you get up to this point. Alright. Last step that you need to do is simplify. Okay, if you look at the left hand side, it's already in the most simplest form. Okay, so you just write down again. However, this part, okay, the m here you can cancel out. Okay, and then there's 3l here. So l times with l negative 3, you will get, this is l to the power of 1. Therefore, 1 plus negative 3, you get negative 2, right? And then l negative 2 on the upper side, and then you have L negative 1 on the lower side. So negative 2 minus negative 1, which is actually negative 2 plus 1, which is negative 1. There you go, you have negative 1 here. And then this t here is negative 1. However, on the downside is negative 1. So if you bring it up, you will get t to the power of 1. Okay, so you get TL negative 1 on the right hand side and LT negative 1 on the left hand side. You may write it down in terms of this form, okay, so that you can compare easier. Okay, so you get LT negative 1 and L negative 1T. Therefore, it is definitely not equal. Thus, the equation is not dimensionally correct. Alright? It's not homogeneous. Okay, so that's how you do dimensional analysis. Okay, if you refer to past year question, you should have noticed that 2 years in a row question regarding dimension has come out. Okay, so we're gonna look at those two questions. Alright, so this is 2019 and 2020. Okay, given to you gravitational acceleration, AG symbol. So gravitational acceleration you will learn in chapter 7 gravitation this semester. Okay, this is the formula given. It's given, okay. So you know A is acceleration, okay, and then given M and R is mass and radius of Earth respectively. So you know what M is, you know what R is. Okay. Now G is constant here because it asks you to find dimension for constant G. First step is write down again the equation given and then rearrange the equation so that the one that you are supposed to be focused on is the subject. In this case, the constant G, right? Okay, so let G here be the subject. So you rearrange, so you will get this AG R squared and then M over M. Okay, and then what you do is you put dimension for all physical quantities present. Okay, so on the left hand side you have G here, constant G. On the right hand side you have AG, so you put square bracket, and then you have R, you put square bracket, and then you have mass here, square bracket. Okay, what you did here is dimension to the physical equation. So AG here is LT squared, LT negative 2, sorry. And then R here is radius, which is length, L squared. And then M is mass. Okay, so you substitute all the dimension symbol. And then last step is to simplify. So L and this L, you times it together, you get L cubed. And then T negative 2. And then M here, you bring it up. So you get M negative 1. So you have dimension for G here. Okay. So next, PSPM 2020-2021, which is last year, you have Hooke's law states that the restoring force is proportional to elongation. So you have Hooke's law equation like so. And then you have Newton's second law, which states that F equals to ma, where m is mass, a is acceleration. Okay, and then it asks you to determine dimension. So this is the first question it asks you to find, and the second one is the SI base unit. All right, for what? For constant K. As you can see, you can rearrange the equation so that the F is equal. So you will have negative kx equals to ma here. Okay, and then you need to be focused on K. So K will be the subject. So you bring x to the other side, you will get this equation. And then you also bring the negative here. Okay, now we put dimension for all physical constant. So K included, okay. So M here, A here, X here. Notice that the negative has gone because negative is dimensionless. Okay, so never bring the negative down here when you are doing dimension. Okay, so put square bracket for all physical quantities, indicating that you are doing dimension. And the next step is to label it with the dimension symbol. Okay, and then after you get M is capital M, A is LT negative 2, and X is elongation, which is actually falls under length. Okay, next, last, you simplify. So the L here can be cross out, and then you leave with empty -2. So this is the dimension for constant K. And then the SI base unit is just one extra step from your final answer for dimension, which is M is mass, therefore SI unit is kg and time SI unit is second. So you get kg as -2 for unit. Okay, so that's all for PSPM question answer. Finish subtopic 1.1. Let's have a look. You should be able to know what dimension is. Okay, you should be able to determine dimension for any derived quantities, and then you should be able to verify homogeneity of equation, whether left hand side is equal to right hand side. So I'm going to stop here. I'm going to proceed the next subtopic, which is scalars and vectors, in the next video. Okay, thank you.